I'm Jonathan Rogers. I work for the Johnson Space Center in Houston, Texas.
And what do you do there?
I'm a robotics engineer, and with me today we've got one of our spin-off technologies that came from the Robonaut 2 project. This is called Robo-glove.
Okay, and what's the Rubble Glove?
This is a technology that we've developed from the Robonaut 2 project in collaboration with General Motors from Michigan. This is a grasp assist device that is intended to help assembly line workers at General Motors or our astronauts in outer space alleviate problems with their hands. It makes grasping heavy objects and moving them a lot simpler by supplementing the human wearer's grasp strength.
Mm-hmm. So, when will it be finished? Is it finished?
So this is, today I'm wearing our first generation. We have a newer one in development that's got more capability, and we're doing trials at JSC to decide how we can help astronauts, and our colleagues at General Motors are doing the same with their assembly line workers.
General Motors in Europe is foremost, of course, known for the cars. Can you drive a car with this one?
You certainly could. It only assists you. It doesn't prohibit you from working with things, but it's really intended for situations where people are working with heavy or bulky objects.
Like cars?
Like parts of cars or parts of space stations.
Mm-hmm. So I reckon you haven't been in space, have you?
No, I haven't.
What do you think it's like? I mean, you know people that's been in space, right?
Sure, we have astronauts come through our lab to try out our technologies and get trained on the projects that we have on space station. They say it's amazing, and I think every single one of them, there's always a little part that doesn't want to come home.
I see. And when they ask you to give them a hand, is that what you give them?
One of the many things that we can help the astronauts with.
Mm-hmm. So why is this important for astronauts? I mean, when they're out in space.
Sure, that's a great question. This is important for astronauts because when they're in their pressurized spacesuit, a lot of effort goes into just fighting the balloon force of the glove. So while they're trying to assemble parts of the space station or make a repair, it's a lot of effort just to move your hand, not to mention doing the work. So if we can use a technology like this to help them fight the glove, their life is going to be a lot easier out there.
Okay. Could you think of any, other parts of society where such a glove could be useful to have?
Another great question. So when we did the press release for this technology, we've been contacted by people from around the world with other ideas for us. Some of them include stroke victims or other folks who need help holding on to objects just in daily life. So it's not really just restricted to space or assembly line work.
Mm-hmm. So medical use, for instance, is that a part of it?
Sure, that's one of the limitless possibilities for using robotic technology in daily life.
Mm-hmm. What do you think about us in Europe, Jonathan? Could we use a hand like that?
Sure. Y'all are doing the same things day to day that we are here in the U.S.
Mm-hmm. So will you share that with us, or will we have to wait?
Well, we don't have any plans to commercialize it just yet. But believe me, that's one of the things that we're working through.
Mm-hmm. Because a lot of the stuff you are developing is eventually being commercialized, isn't it?
That's correct. NASA's role in this is, to develop technologies that help us in space, but also have applicability here on the ground.
And why is that important, do you think?
There's been a number of innovations that have come from the space program to, that have come back to Earth and really helped enhance daily life. Everything from personal computers to Velcro, has some of its origin and some of its history in the space program. So, even though we have our focus set on the stars, we always remember that the things that we do have impact here on the ground. So,
basically, we have to reach for the stars in order to get to know what's really important here.
That's very true.
On the ground?
Absolutely.
So, as a conclusion, how will this robo hand, help us reach for the stars, do you think?
So it'll make assembly tasks in space a lot easier for astronauts. They'll be able to work longer and won't be as tired. They can work harder on the things that really matter instead of just overcoming the challenges of being in space.
Could you tell me briefly about it? What's the different things?
Sure. On the palm side of my hand, I have 4 brushless DC motors, 4 electric motors, that pull tendons, which allow the glove to supplement my grasp strength. They run through my wrist area and then are anchored around my fingers. So really the glove is using my body as its structure, but it's providing the force.
So how powerful do you get?
You can get 5 to 10 pounds of extra grip strength over what a normal person can exert. On the back side here are the electronics that run the glove, and then I have a simple battery clipped to my belt. It's all activated by a switch, a pressure-sensitive resistor that's underneath my thumb.
Okay. So you when you grab something, you automatically activate it.
That's correct.
Okay. Is it cool, do you think?
Oh yeah, it's great. I mean, how many people get to say they can wear a robot?
But you do. Do you have one of them home? Back home? One of them?
One of the gloves?
Yeah, the gloves.
Yeah, this is our first development unit, and
in your home.
No, I don't have one at home yet.